if you remember one thing from quantitative methods, I think it's the following. It is that equations are things that we use for arguments in economics. And the equations that we use say very, very specific things about our variables. And choosing the equation is really important because you're making an argument. And once I've chosen the equation, I've won the argument. And so this video is just a basic overview of how to use math to make an economic argument. I think a little story might help. My stepdaughter was visiting this summer, and she just finished Algebra 2. And so maybe this is something that what her book looked like. And being the econ and math geek that I am, I asked her, well, what do you remember about the class? And with some prompting, she gave me an answer that was something like this, the infamous quadratic equation. And I said, well, why did you learn that? She goes, I don't know. I've been asking myself the same thing. And what her teacher failed to do is to provide some meaning or context of why a quadratic equation could be useful beyond answering a question on a test. And so I showed her a picture of this guy, a mosquito. Now, mosquitoes carry different diseases, one of which is Zika. And last year, and perhaps this fall, there are outbreaks of Zika in parts of the United States. And suppose that we had data. We had 3 data observations of, on this date, number of new cases, on another date, a number of new cases, and so on. And if I have 3 data points, I can use a quadratic equation to estimate when this Zika outbreak might be over. And that can actually be pretty useful. And so using math can be quite useful in making a specific argument. So the takeaways from the next few sessions in quadratic equations are, number 1, argue the assumptions, not the math. And that before you click on a trend line in Excel to make your graph spiffier, make sure the equation type makes sense. Make sure that the argument that it implies makes sense. So I'd like to examine that second little sticky in more detail. I have a friend named Jim. Jim's a cyclist. And Jim was the executive director for a cycling club. And the cycling club, although it had sponsorship, it relied a lot on membership dues to fund some of its activities. And so one day, Jim gave me a call on the phone. And he said, we have currently about 500 members. And each month, we expect membership to increase by 50 people. And so he's thinking something like this. I thought, well, why not 54? Why is it 50? And also I was arguing, there's something else that you're implying by that statement. So let's look at Jim's statement in a little more detail. And so January 1st, they had 500 members. And what he's saying is that each month, membership's going to grow by 500. And so I can write this as an equation that total membership at any given point in time is 500 plus 50t, where t is the number of months since the beginning of the year. I could also look at it on a graph, where I put time on the horizontal and the number of members on the vertical axis. I'm starting with 500, and each and every month I have more, so that by July, I would have 800 members. And so what Jim was telling me is that new members increase by the same amount each month forever. And I was like, does this make sense? Because that means that it's not a celebration time, perhaps, but the membership growth rate's actually slowing. And in fact, if you graph it, it looks something like this over time, that the growth rate is falling. And so the moral of the story is that when you write an equation, you're describing behavior, and make sure that behavior makes sense.